Hey, I'm Charlie Thompson, and this is the Lab 14 Rivers video. I think these are going to be the shortest slides of all of the labs. There's no new skills this week. You're going to be finding distances, you're going to be finding relief, you're going to find slope in feet per mile. I included a Google Earth project. There's no KMZ file to download. That's the good news. The bad news is you can't do the more sophisticated, really cool stuff like bringing in an image and draping it over the landscape like I think I did in... Nope, we didn't do that yet. Maybe later we'll do that. So there's a really cool thing you can do in Google Earth, and that is you can take an image like a topographic map and you can drape it over the landscape and you end up with a 3D topo map, which is really cool. But you can't do that with the Google Earth projects. On the other hand, I can send you a link and it just works. So I think that's going to be great going forward. So here's the first map, figure 14.1. We're going down the Sacramento River. The yellow line is the county boundary. The blue line is the Sacramento River. Here's Dunning Slough up here, and here's Ord Ferry Road down here. Part of what you're going to be doing is calculating the sinuosity, or how curvy the river is. And so there's the river distance, which is if you were sailing down the river, how many miles that would be, and then the straight line distance, which is just going from this place straight down to that place. And it's the difference in those two lengths. The curvier a river is, the higher the sinuosity is. So here's Dunning Slough. Here's some contour lines. There's like a 140-foot contour line, 130-foot contour line. You can see, for example, here's the county boundary again compared with the river boundary, and you can see this is why you should never use a river as a political boundary, because the river is going to move and then you'll just look silly, because you can see Jenny Lind Bend, the river used to go there and the river used to flow up there, used to flow down there, but it doesn't anymore. So the river shifted and now you look silly. Here's the middle stretch, Phelan Island and Golden State Island. After you watch the Why Do Rivers Meander video, the question about Golden State Island and Phelan Island will make more sense. And then finally down here, I can't put my mouse over that part because it gets excited. All right, Ord Ferry Road down in the lower left. You can see there's a contour line that goes right over the river. That'll make it easy for you to find the elevation. Oh yeah, look at that. There's 110, and that's lower. Bottom of the map gives you the contour interval and the scale. So that's the first map. The second map is a map showing river channels, color-coded. Red is the newest, blue 1896 channel, so that would be the 1896 channel. They say for good map design, you should never use more than 9 colors because you can't separate them out. And like the blues start to run together. So I'm going to ask you questions about the river channels and like how long ago was there water flowing through this section. Just give it your best guess. So there's that. And you'll notice well, you can't tell from there, but you can tell from here. And here, the maps, the first 3 maps are all the same. They're all showing the exact same area. The difference is that the first one is a topo map. The second one is, well, this would be aerial imagery with a vector overlay of the abandoned past stream channels, showing what an active river that is. Nice. And then this is a map that I made. In fact, I made that one and I made that one. This is a digital elevation model, so it's color-coded by elevation above sea level. And one of the cool things about DEM imagery is that often you can see things on the DEM that you can't see on the topo map, or maybe not even on the aerial imagery. So there's all kinds of features that I'm hoping you can pick up on. Oxbow lakes, meander scars, abandoned channels, all those features. Next up, the Cumberland Gap. So actually, this is the Cumberland Narrows. I thought for years it was the Cumberland Gap. Cumberland Gap is another stretch. So there's this big ridge. Hopefully, looking at it, you can tell it's a ridge because the concentric rings get smaller up there at the top. So that's got to be a peak. You can see it's steep here, it's flat here, it's flat down here, so there's water flowing through it, so that's a valley. Here is a long ridge with this river cutting across it. So the dealio is the river was here, and the river kept cutting down, and the land, either materials removed, or because of tectonics, the land was getting pushed up, and the river just kept cutting down. So here, this is a water gap, where the river has actually cut down through this ridge. And down here where it says Braddock Road, that's a wind gap. So there used to be a stream that flowed through there. It doesn't. It stopped. And so when it stopped flowing through there, it stopped eroding and stopped cutting down to the level of these two valleys on either side. Okay, so if we zoom in a bit, here we've got the Narrows with the water gap. You are supposed to determine how wide it is, what the distance is, and I specify where to start, where to end, and what actually, I think I've measured it for you and told you what that measurement is in inches. And since the map, you know what the map scale is, and you know how many inches across it is, you can figure out how many feet across the gap is there. Also taking from this contour line down to the Narrows down in here. And there's a contour line right on, yeah, you can kind of see it peaking there, kind of see it peaking there. Here's an index contour, and then there's one lower than that before you get to the river on the railroad track. So that's the contour line that you're going to use for the bottom of the Narrows. And then the last thing you're going to do is figure out some stuff about this wind gap. So here's Braddock Run. Here's the contour line that goes under the R in Braddock Run. This index contour, I think, just wraps around. So if you can figure out whatever that contour is, that goes right under, what is that, Highway 68, Highway 40. That's an index contour at the bottom. I don't remember which of these contours I told you to use at the top. So you're going to calculate how deep the wind gap is, I think, and then also how high the wind gap is above this valley that Braddock Run, this stream, is running through. So that's it. It's supposed to be a short lab. I know it's Thanksgiving. Hopefully it'll be fun. Hopefully you'll enjoy it. And I wanted to demonstrate. I didn't do it. Okay, so down at the bottom, here's the Google Earth project. I'm just going to test this and see what happens. So you click on that. I'm going to go full screen. Ah, fantastic. So we've got a bunch of points. And also a very important part of this, I would recommend, so when you click on a point, it'll fly you there. But part of what I'm hoping you'll do is also to, oh, like, what is that? Oh, man, Google Earth, you're so amazing. Like, I think this stream is really interesting. You can see the point bars and the cut banks in that stream. But then I just realized, what is... Oh, that's totally interesting. Oh, it's aspect. Oh, how fun. Right. So looking at this, you can see the streams. The streams are outlined, but they're outlined with trees, and the trees are growing on the south side of the river. So that if you were the sun looking at this location, you would look at it like that. If I zoom in a bit more, you can see, oh yeah, that's a south-facing slope. That's a north-facing slope. If I turn it around so that we're looking at it from the north, north-facing slope, north-facing slope, north-facing slope. All the north-facing slopes have lots of vegetation because they're in the shade, so they have more moisture. So anyway, once you zoom to these places, like there's the starting point, and in blue, let's just zoom out. In blue is the straight line distance, and in red, so like river miles, I'm giving what the river miles is, and here's the straight line distance, so you can figure out the sinuosity. If you put your mouse over the starting point, down in the bottom right-hand corner, it says 364 feet, so we know the starting elevation. And then we can do the same thing. Ending elevation, 348 feet. 364. Cool. So we've got, and then on the lower river, oh, right. So the point of that was I thought it'd be fun to calculate out, calculate the difference in gradient at the upper reaches of the Sacramento River, where it's more of a wild river. As you all know, the longitudinal profile of a stream, it's usually steeper where it starts and it's flat where it ends. So I thought it'd be fun to calculate out what the difference in gradient is between the upper Sacramento and the lower Sacramento. So let's go to the lower Sac. So here's the lower Sacramento, and here's Hamilton City. So this is the stretch that is in your map. This would be figure 1, 2, and 3. And yeah, one of the things you should be aware of is you can turn on and turn off features. Sometimes it's nice to turn them on so you can see what everything is. Sometimes you don't want all the words and you just want to look at, just want to look at Earth and wonder, like, how long ago? Oh, there's a good question. Yeah, like, how long ago was that abandoned? Looking at the river channel map, you should be able to figure that out. What is that? Figure 2, I think. 14.2 is the map with all of the old traces of the channel. Then there's this weirdness down here. These might be Yazoo tributaries, which are streams that want to go into the Sacramento, but because of the levees on either side, the natural levees, they're unable to flow up and over the levee because water doesn't flow uphill. More abandoned features. And then as you get down into the southern part, there's Princeton, where there used to be a ferry, a boat that would actually take you across the Sacramento River. I'll bet it was right there. Anyway, agriculture, we've got Boggs Bend. How long ago was the river flowing through you, Boggs Bend? And then where are we getting close to Colusa? I thought that was fun. So if I open that back up, yeah, I thought you'd get a kick out of Colusa because Point Bar, Cut Bank. What's going on with Colusa? Just downstream from Colusa is the Sutter Buttes. What drainage pattern is that? Here's the beginning of the Sutter Bypass that flows down into the Yolo Bypass. And there you go. So, yeah, there's the Sacramento Weir where they open up and flood the bypass. And then I also included the Susquehanna River Water Gap. So, yeah, one of the great things about Google Earth, you can actually see how steep those ridges are and how dramatic it is that the Susquehanna River has cut through those ridges. Yeah, just incredible work. And then I thought you ought to see what the Cumberland Narrows water gap looks like in Google Earth. You've seen it on the topographic maps. What does it look like for real? And then also the Braddock Road wind gap. Yeah, that's such a weird idea. Like I never would have thought of that one. Okay, so those are all the Googly Earth features. I hope you get a kick out of that. You should look forward to another one of these tours for the chapter on glaciers. And also, yeah, it would be great if there was, because you can make your own KMZs and then you could share them with me. That's going to be step 2 in my online lab experience, would be have you create your own KMZs and submit those, either sharing it. I was going to say, also you can click on present and you can just click through starting point, ending point, river miles. So yeah, you should know that if you click on present, you can just click through and it'll automatically fly you to each of those. And there's a little pop-up window that should give you information. That's weird. There you go. River miles lower, straight line distance lower, Colusa. Anyway, I hope you get a kick out of that. I hope you enjoy it. I hope you play around and look at your house and look at the places that you've been in Google Earth.